and I just wrote a new project. And you'll find it down here in post-quantum cryptography. The only one we had was Baby Kyber. I'll just mention there's a couple of new ones here where you set up an HTTPS server with post-quantum cryptography, which is pretty easy. First, you need an HTTPS server. So you make one here. And I'm going to use Debian and Apache. So you run Apache, then you get your IP address, then you make a DNS configuration so you can have a domain name, and you put it in your own hosts file, so it's not on the internet and you don't have to pay for it. You can only use it on your own system. So now you have a relationship between your name and an IP address. So now you can open that in a browser, and you'll see your page, but it's not secure. It's an HTTP page right now. So you have to give it a certificate. Now you can generate a self-signed certificate with this command, make SSL search, which is part of OpenSSL. And now you just turn on, this enables the encryption module in Apache, and then you create a file that tells it to make a virtual host. And use these snake oil certificates, or what they call them, ones that are self-signed. They're not actually approved by a certificate authority. So again, they won't give you full security, but you're able to see how they work. And then you enable the site and restart Apache, and now you can open HTTPS, your name. But it will warn you there's something wrong with the certificate, and you have to proceed to it down here. And your browser will warn you that it's not really secure because of lack of a security authority, but we don't care about that. What we care about is the encryption method it uses. And right now, you can examine it in Wireshark. So send some pings, sniff on the right interface, which can be a little hard to find because you're going from your host to a virtual machine. The traffic is not going out on the internet, so you have to look at one of the other ones like VMnet 8 or VMnet 3. But when you find your pings, then you've got it. So then you can look for the 443 traffic. And the traffic on 443, you'll have a client hello and a server hello as the TLS negotiation happens. And your client hello, what's that?
The handshake.
That's right. This is the TLS handshake. So your client, and I say you have to use Chrome, I think, or Chrome compatible browser, and it will then offer various things. Grease is an optional thing that, that Google has added to detect certain flaws. It's a test protocol. But anyway, so that's the first handshake. This just means you have an HTTPS server using normal HTTPS. So that's the first thing. Once you have that, you can then upgrade this to a quantum-resistant encryption, which is new and cutting edge. So what you do is you go to this one. Once you have that server, then you go into Chrome Developer Tools, and it will tell you it's not secure because your certificate is not coming from a trusted authority, which you know, but it is using TLS 1.3 with X25519, which is elliptic curve cryptography, and AES in Galois Quantum mode, which we talked about. This is the modern version of AES you should be using. So this, in fact, is currently considered secure, but both of these are going to be broken by quantum computers. Elliptic curve cryptography is going to get broken, supposedly, in a couple of decades, and AES 128 is likely to get broken. So you really should be using AES 256. We're not going to fix that problem today, but we're going to fix this problem. We're going to switch from public key encryption to the modern quantum-resistant public key encryption. So, all right, so what you do, if you examine the server hello, you're going to see, now your client hello offered to do this unknown 11EC is a post-quantum algorithm called MLKEM, one of the Kyber algorithms. So the Chrome now by default enables it and offers to use it. So if you look at the client hello, you'll see your browser offered to use 11EC, which is so new, Wireshark doesn't know what it is yet. But it is the post-quantum encryption. But the server will not choose it. The server will choose X25519 because your server is not yet using post-quantum encryption, even though the browser could. That's what we're going to fix. So you get an OpenSSL, you have to have a recent version of OpenSSL, and here's where you download from GitHub the encryption software that implements this post-quantum encryption and build it. You have to compile it yourself. It's not in the repositories. It's all very new. Then you can run the tests, and it passes the tests, so your compiling is correct. And now you have to add it to OpenSSL. You do it by uncommenting this line, so it will have other providers, and then you have to add a section at the end telling it to use your new post-quantum provider, OQS provider. And then when you list the providers, it'll now have, in addition to the default provider, it will have this OQS provider, which is the post-quantum encryption provider. And now, when you list your algorithms, you'll see a lot of them, including the one we care about, which is X25519 MLKEM. This is the Kyber encryption, which is combined with the elliptic curve encryption for some reason, but this is the part that makes it quantum safe. That's the modern one. And looks like I've got to fix my format here. But anyway, this is how you configure these lines in your Apache configuration to use them. And now, when you're done, you'll now see that it's encrypted with this X25519 MLKEM, which is the quantum resistant new algorithm. So it's pretty easy to do, and I put it here so you can practice doing it. That's what we're all going to have to do. They say within the next, we should start doing it now within the next 5 years. We should move everything to post-quantum encryption, because people are saying those quantum computers are going to be available in perhaps as little as 7 years. Microsoft just had a new form of qubit, and they claim it will scale up faster, and they claim they'll have a working quantum computer with 1 million qubits in 7 years, which I doubt, but if they do, we better quit using these algorithms that will no longer be safe, and we ought to get practice upgrading to them.
I was reading the criticism of some experts.
Yeah.
They were saying that they don't believe all the hype that Microsoft
Yeah,
said around.
I don't necessarily believe it either, but I do believe in like 20 or 30 years it'll come. So upgrading now is a wise move. But yeah, it's all speculative. If they never get a working quantum computer, then we're wasting our time. But you know, we're all in the business of risk. We have to mitigate reasonable, foreseeable risks. So if there's a 10% chance that someone can crack it in 10 years, then we shouldn't keep using that algorithm. Yeah. Especially when there is another algorithm available and it's even approved by the government. So, you know, there's not much excuse for not using it now. So I'm going to stop this one.